Hey, how's it going? My name is Mr. Milanese, and today we're going to talk about one-step equations. Okay, so one-step equations get their name because obviously they can be solved in one step. Here's a good example. X plus 15 equals 23. Now the objective, of course, is to solve for x, your variable, and we're going to do that using inverse operations. So the first step is to figure out what is happening to x. In this case, we're adding 15. What we would like to do is the opposite, or the inverse, of plus 15. And the opposite of adding is subtracting, so we're actually going to subtract 15 from both sides of the equal sign. Sometimes you'll see teachers draw a little line here. They'll call it the river or the bridge or whatever. And it's just to help you remember that you have to do, since both sides are equal, you have to do the same thing to both sides. So we've identified that right now we're adding 15. The opposite is subtracting 15. But not only do we have to do that on the left side of the equal sign, we also have to do it on the right. Okay, so let's update our equation. Positive 15 take away 15 is 0. We can cancel those out. And we're going to drop down our variable, and we have our variable by itself, which is what we wanted. We still have our equal sign. Don't lose track of where it's at. It's in the river. And then on the right-hand side, we're just going to do the subtraction problem. 23 subtract 15 is 8. So x equals 8, and that is our final answer. Now, one thing that you might want to do is you might want to check yourself before you wreck yourself. You better check yourself or you wreck yourself. Here's how you're going to do that. We're going to see if x really does equal 8 by substituting it into the original equation. Here's what it should look like. Instead of x plus 15 equals 23, I want to see if 8 plus 15 really does equal 3. So here, instead of x, I'm going to substitute in what I think x equals, which is 8, and then I'm going to copy down the rest of the problem exactly how it was. Okay, now this might feel a little bit weird if you're not used to doing this, but 8 plus 15 is 23. I'm going to drop down to the next line, and I notice that 23 equals 23. In other words, it's the same on both sides. So in this case, I would say that the answer is correct, or it checks out, simply because I know that I have a true statement. I know that 23 really does equal 23. So the right answer is x equals 8. Okay, so let's try another one. This one says 0 equals p minus 6. Obviously, this is a subtraction problem. So the first thing is find out where the variable is. In this example, it is on the right-hand side of the equal sign. And the operation is subtraction. We're going to use the inverse of that, or the opposite of subtraction, which is addition. So I know that I'm going to be adding something to both sides of the equal sign. I obviously want to pick the same number, so instead of minus 6, I'm going to put a plus 6 on both sides of the equal sign. Here's what that does. Negative 6 plus 6 is 0. Those cancel out. They're no longer there. And I can drop this down, my variable, which is p, and then all we have to do is work on the left-hand side of the equal sign. 0 plus 6 is 6, and so here's our final answer. 6 equals p. Now, you could just as easily flip this to say p equals 6. Sometimes we're used to seeing that variable on the left-hand side. But once again, we're going to check ourselves to make sure that this is the correct answer by substituting this number back in up at the top, just to confirm that it does actually equal what it says it does. So let's fill out our equation. 0 equals, instead of p, I'm going to substitute in the value that I think is correct, which is a 6, and then we're going to copy over the rest of the equation. Well, now we can do this part in our head. 6 subtract 6 is 0, and so we wind up with something that says 0 equals 0, which we know is true, therefore we know that we got the right answer originally. Okay, so how do we handle a multiplication problem? Well, this problem says negative 3 times x equals negative 45, and we're trying to solve for x. So again, I want to identify where is the variable. Right now it's on the left-hand side of the equal sign. And the operation here, when you just have a number right beside a letter, that's multiplication. So this is, a lot of times people get this confused and think it's subtraction, but that's just a negative sign. So this is multiplication. The only way we can undo, or the inverse of multiplication, is division. So we're going to draw a fraction bar on both sides because fraction bars mean divide. And we have to divide by, here's a fancy word, the coefficient. That's the number that's out in front of a variable, exactly as you see it here. I have to pick a -3. I can't divide by 3, that's not going to help me. I need to pick the coefficient, which is a -3. So we're going to divide by -3, but if we do it to the left side of the equal sign, we also have to do it to the right side of the equal sign. Okay, -3 divided by -3 is a 1, and 1 times x is x. So we can just eliminate those and jump straight down to x by itself, which is what we were looking for. Don't forget to rewrite your equal sign. And then we've got to either get a calculator or do this in our head. -45 divided by -3. Now don't forget, a negative divided by a negative is a positive. 45 divided by 3 is 15. Here's my final answer. I think that that's right. If this is a quiz or a test, I'm going to check myself, plug this number back in, and make sure that it actually works. So let's rewrite down the original equation, -3. Instead of putting an x, I'm going to put the number that I think is right, which is 15, and I'm going to put this in parentheses. The reason that I did that is because this is multiplication, and if I just put the 15 beside the -3, it might look like I was trying to write down the number -315. So just to avoid any confusion. And then we have the equal sign and then -45. Let's see if this actually does work out. Well, -3 times 15 is -45. And once again, we get it to check out. It works on both sides. So I know that this is the right answer because when I substitute it back in, it works. So x equals 15. Okay, so let's finish this up with a division problem. 9 equals k divided by 6. Once again, look and see where the variable's at. In this example, it's on the right-hand side of the equal sign. So I like to draw my line just to keep straight where I'm at. I notice that the operation here is division. Fraction bars mean divide. Well, think about inverses. What's the inverse or the opposite of division? It's multiplication. So all I'm going to do is the inverse of what's happening to k. Right now, k is being divided by 6. I can reverse that or do the inverse by multiplying by 6. I just put a little dot to show multiplication, and then I come over here to the other side and put a dot as well. 6 times 9 is 54. And these 6's cancel, again, because 6 divided by 6 is 1, and 1 times k is k. So anytime you have the same number in the numerator and denominator, you can cancel them. So here's my final answer, k equals 54. Once again, though, it's wise to go ahead and substitute it back in to check and make sure that the answer is correct. So I'm going to take 54, I'm going to go back to my original equation, rewrite it down, but substitute in a 54, and see if everything turns out okay. So 9 equals k over 6, but instead of k, I'm going to put a 54 divided by 6, and let's see what we get. Well, our 9 just drops straight down. 54 divided by 6 is 9, and so we have 9 equals 9. So I know that this is the right answer. Plugging the numbers in or substituting the numbers back in to check, especially with the one-step equation, is kind of boring, not really that satisfying. However, when these equations start to get way more difficult, it's nice to have this skill in your back pocket so that you can check yourself to make sure that the answer is right. So that is how we solve one-step equations.